Your furnace and air conditioner exist because the heating industry hid the fact that the dirt under your house already does both jobs for free. That dirt sits at 52 degrees year-round, 6 feet down. In July, it drops your incoming air 30 degrees before it ever reaches a vent. In January, it warms that same air 20 degrees before your furnace ever kicks on. The whole setup costs $500 and runs on a single recovery loop your contractor pretends doesn't exist. Researchers in Greece proved the math worked in 1994. Canadian engineers built a house that needed no furnace through a brutal prairie winter in 1977. None of this is theoretical. Your air conditioner doesn't cool, it moves heat. And there's something already sitting under your foundation that moves heat better, cheaper, and forever, called the soil battery. First off, every air conditioner on Earth is a heat pump running in one direction. Your central unit doesn't generate cold. It grabs warmth out of the air inside your house, ships it through copper coils, and dumps that warmth into the air outside. That dumping step is where the whole industry breaks. On a Phoenix afternoon, your condenser coil tries to push heat into 115-degree air, and physics doesn't let you push heat uphill without paying for the climb. 150 degrees. That's how hot the refrigerant inside your condenser coil runs while it tries to shove that heat into air that's already scorching. Your air conditioner always loses that fight, which is why your bill doubles in July. The soil battery solves the dumping problem at the source. 6 feet below the ground, no matter what's happening up top, the dirt is sitting at 52 degrees. That number doesn't move. It doesn't move when the air is 110 outside, it doesn't move when the air is 20 below. Sun heats the top inch of soil every day, but that energy never reaches 6 feet down. Soil conducts heat about as well as concrete conducts electricity, which is to say barely at all. Below 3 meters, the temperature is what physicists call the undisturbed ground temperature. The dirt under your home is a thermal reservoir the size of every basement on the block, sitting at a constant 52 degrees, doing nothing all year. A buried 4-inch pipe takes outside air, drags it through that reservoir, and hands you air that's already given up most of its heat before it reaches a register. Greek researchers Michalakakou, Santamouris, and Asimakopoulos published the model in 1994 in Energy Conversion and Management, varying pipe length, pipe radius, air velocity, and burial depth. The numbers they got back matched the cooling every Persian wind catcher delivered thousands of years ago. The pipe does the work your air conditioner pretends only Freon can do, and the pipe runs on the heat reservoir your house is already sitting on. There's a reason the Persian engineers buried their cooling channels at exactly the depth where the soil temperature stops fluctuating. They didn't have refrigeration math. They had 1,000 summers of trial and error always lands on the same physical truth the engineering papers landed on thousands of years later. The soil battery isn't new technology. It's the technology your air conditioner was built to obscure. But here's the part that turns a summer-only trick into a year-round system. You're probably thinking, fine, a buried pipe is great in August, but what happens when January air hits the same pipe? The answer is that 52-degree dirt is now warmer than the air, and the same pipe preheats incoming air 20 degrees before your furnace ever wakes up. That single fact already cuts a winter heating bill in half. Your furnace only has to cover the gap from 52 up to 72, not from 20 up to 72. Now bolt on the second piece, the part the heating industry treats like a secret, and the system goes from cutting a bill in half to nearly erasing it. The piece is called a counterflow recovery loop. The technical name is heat recovery ventilator. Inside is a flat plastic core with 2 airstreams crossing past each other, separated by thin aluminum or polymer plates. Warm outgoing air gives up its heat to cold incoming air through the plate without the 2 airstreams ever mixing. Sensible recovery efficiency in a residential unit runs 60 to 90%, and a good counterflow core lands around 80%. That's the heat your warm bathroom exhaust hands back to the incoming January air. It all happens in a small box bolted into your duct chase, with no compressor, no refrigerant, and no moving parts beyond 2 small fans. So picture the whole system in winter. 20-degree outdoor air enters the buried pipe. The soil battery hands it 20 degrees of free warmth, and it exits the pipe at 42 degrees. That 42-degree air then enters the counterflow loop, where 80% of the heat in your 70-degree exhaust air transfers through the plate. The incoming air leaves the recovery core around